Welcome to today's webinar session, Fundamentals of Information Management. Grant International Company is very delighted to engage with you with our webinar series on different topics related to AEC industry and digital transformation. Before we get started, I'd like to go over a few housekeeping items regarding today's event. First, the presentation audio is only supported through your computer speaker system. If at any time you experience audio issues, please try refreshing your browser or switching browsers. Secondly, all attendees will be muted throughout the session, and everyone can submit text questions by typing them into the chat section of your control panel. You can enter your questions at any time, and we will address them during the Q&A portion at the end of the presentation. If you don't get enough time to answer all your questions due to time constraints, it will reach you as a mail later. Before going to today's session, I would like to give a quick introduction to our company, Grant International Qatar and Kuwait. About us, we are an engineering solutions company providing technology solutions and services to the construction and manufacturing sectors. We have regional offices in Kuwait and Qatar and a near future expansion to Saudi also. We are one of the largest enterprise software and hardware resellers. We help our customers with solutions like Autodesk, Adobe, Solibri, Transoft, and many others bring their products to the market, and we offer a wide range of technical and business support services. We offer a range of different consulting services depending on your needs. Our ultimate goal is to ensure we deliver practical and affordable solutions for your organization based on your current and future needs. Our services include BIM software workflow training, BIM consulting, BIM implementation, and for any additional information, feel free to reach us. We are located in Mumtazah. And now we can switch to our main agenda. Over to you, Shiaz.
Thanks, Mira, for giving an opportunity to work with. And let me share my screen here.
Okay.
Welcome all to today's session, Fundamentals of Information Management. This session will be a baby step towards understanding the BIM fundamentals as well as to the global BIM standards like ISO 19650. And I would like to start this presentation by going through a small poll in order to identify your organization. I can just share I would like to share a poll question. So it will be available for view for 30 seconds so that you can able to answer it so that I can understand from which organization you are representing. Let me start with my first poll. So I believe everyone can see the poll question right now so that you can just simply submit your answers. It will be there for 30 seconds. After that, we can continue with further. Okay, so from the audience, I believe most of them are from the consulting and contracting sides of the industry. Yeah, we can proceed further with our main agenda, the fundamentals of information management. So let me start this session with the topic, the definition of the BIM. For the perceivers, there are different definitions for BIM. If we can tell in a very simple term, BIM is the process of creating information model. And what is an information model? Information model is actually a digital replica of the asset that we are going to construct on site. And this information model contains all the information from all the stakeholders which is involving in a project. And it will contain the entire life cycle information regarding the asset. And if I'm telling this thing in a very detailed fashion, we can just say building information modeling as an integrated process built on coordinated, reliable information. And it is used to create coordinated digital design information and documentation to predict performance, appearance, and cost, and to deliver the project faster, more economically, and with reduced environmental impact. And the fundamental definition of the BIM is always there is a single source of truth. The NBS UK defined BIM as a process of creating and managing information on a construction project across the full project lifecycle. And the ISO 19650 series global BIM code is not really into the information modeling side, but it is more relevant to the information management side. So this ISO 19650 defines BIM as a more systematic and standardized and where appropriate security-minded approach to managing project and asset information can deliver time, cost savings to the overall delivery of the project and to all life cycle management of an asset. So in other aspects, building information modeling it's not only for the buildings as the name says, it is for all the assets like linear infrastructure and for vertical infrastructure. In general terms, not only for the buildings, it is for roads and plant kind of structures that we are about to build. And BIM is not just a 3D CAD. Definitely this 3D and CAD are part of the process. And some of the customers are there just saying that we are into BIM. Why? Because we are just using this particular 3D CAD software. But it is not true in full. In actually, these things are part of the process, but it is not only the 3D CAD software. And one another terminology is like BIM is a new technology application. Definitely technology is a key part and it is an enabler, and it is not a next generation process. It is here and it is now. So for the BIM acronym, it is different meanings to the different perceivers. The first acronym that we are always using is building information model. That means the output or the thing which is produced. This is actually the information model, or in simple words, the content being created as a result of the process. And the building information modeling is the another term that we are commonly using. This is the answer to the question how the thing is being produced, and which means the process itself. And the third term is the building information management. This answers to the question who, what, and when produces the thing. In other words, the control and the management aspects of the process to ensure the production of information. This particular part is usually unseen for many of the project task team members. And one last term is the better information management, and some people call this better information management. This is not necessarily what BIM means, but it is truly encompasses what information modeling should do. This is to provide better information management throughout the life cycle of an asset. And it is for all kinds of assets, like I have said earlier. It is for building and for the infrastructure also. The contents. There is a misconception generally within the industry that building information modeling is a single 3D file filled with information. In fact, the information model consists of a myriad of files associated. Well, of course, knowing BIM is a part of drawings and 3D models, but in reality, it is much more. Not only the drawings and 3D models, but absolutely as a part of the process for a source of associated schedules, reports, lists, photorealistic images and animations, clash detection, GIS information, sense of data, virtual reality, and physical assets and its associated metadata. So in BIM, it's all these things, but more than just this collection of where information is being generated, more importantly is all of this information coming together, been somewhere in the central, being organized in such a way that allows for meaningful information. So why we do collect all this information, and why do we collect all this data, and what we really is looking into achieve with this kind of data? There are three key aspects behind why we do this. And the first thing is to receive the validated data and to answer the critical questions and taking informed decisions, and finally to carry out the key activities. And it is only by having all this data collected from all these resources and managed and organized in a central, we can actually make informed decisions that are also vital for our projects. So some of the key concepts that are vital to realize. The first one is the BIM multidisciplinary coordination. It is one of the key benefits of using the BIM methodology. Standards, methods, and procedures, making sure that the different stakeholders are being involved and all are using the same working standards and procedures. Digital plan of work, very common concept to use, especially in UK. There is a specific digital plan of work to work with. BIM tools and workflows. So these are process driven, supported by technology, and without these, the entire idea of the BIM will not be fruitful. Information exchange formats and standards, information data, like using data as a commodity. Also, in what regard to BIM, you can see it is represented by the circles, and BIM touches a lot of different components. Projects, people. People specifically is broken into individual team, company, or even the industry. Process and technology. Yeah, technology is here. It's all because technology is an enabler. Technology allows users to do with what we need to do. It helps to make collaboration easier. One typical example is we know this COVID pandemic situation. So the use of the right technology make us allowed to collaborate each other, even the team is distributed and not physically seeing each other. So it helps in business continuity and help in data validation, security, and it help in set up the common data environment also. And then as an understanding of the project and asset information, because in the end of the day, what we will constructing is in physical asset in the real world. And it is important that we realize that all of these things that we are taken into account, because all of them interact with the BIM process in some way or another. The BIM dimensions. One aspect that we are talking all about is the BIM dimensions. So what are the BIM dimensions and what does it mean? So basically we can start with the second dimension of BIM. 2D is basically a computer generated planar two-dimensional combination of drafted lines to represent a particular object. And basically, it will not have the information embedded in it, but recently we are hearing about one more dimension, like 2.5D, which represents 2D data with the embedded information. So we can say this GIS data as an example for 2.5D. And 3D is following the further industry developments, following the advent of the 3D objects modeling. Instead of lines, now we are having the 3D models as part of this process. Objects have different data attached, and this data can be existing or as part of the model, or can be referenced from other database or other sources and reference to the model. In construction, when we talk about the fourth dimension, we typically refer to time. Typically, this stage involves integrating the project planning program with the 3D model. This can be done either by including the constructed and demolished program information or assigning it through the additional software. Typically, 5D involves the use of additional software in order to complete the task, takeoffs, and apply additional costs. However, to carry out effective 5D modeling, there are also complex requirements and modeling techniques to enable effective cost takeoffs. And we talk about the BIM users. The BIM users, of course, are quite simply the reason why the client is looking to use this process. What are they looking to gain from this process? And it is very important that the client identifies what are the key BIM users for their particular project and their identified outcomes that they want to deliver in their projects. For example, you can see in the design and the construction phase, in other words, the capital expenditure phase or the CapEx phase. Clear, complete, and correct documentation, of course, a demonstrably, robustly coordinated design, reducing risk during the construction and therefore reducing the construction cost. You can see that these are the key statement a client would make in terms of the benefits that they are looking to get from the BIM process. Improving tracking of potential problems and installing of commissioning of the equipment. Remember, we are all talking not just about the design, but the construction as well. The CapEx always focus on defining, creating, rebuilding, redeveloping, and the decommissioning of the assets, and thereby creating the value. And I want to talk you about this in detail, but of course, there is a second part of this to any project, which is after the construction is completed and we are handovering to the operation of the physical asset in the real world, and keeping them uses those key BIM reasons. In general, we will say this as the operational expenditure phase or the OPEX phase. Why we are looking to use a BIM process to benefit the operational aspects of a project. To validate the brief has been made to make sure that the outcome the client requires has been realized at the end of the project. Early visibility of the operational cost is vitally important that we keep not only on the top of this design and the construction cost, while ultimately the operational cost should be in the years ahead. Monitoring and tracking of the current requirement, transparency of the design processes, and easily accessible design and for main information presented visually for non-technical stakeholders are all key aspects of why we are understand the BIM users that we need to use this information for. OPEX is focused on the things related to the enhancing asset performance, improving availability, manage, maintain, and improve the assets and predict the asset performance. And one of the challenges the industry is facing right now is there is a disconnection between the CapEx and OPEX phases. And that is, BIM is really focused on the design, construction, project oriented, and operation. And maintenance is taken in a different perspective. The real purpose of the BIM is to bridge the gap between these two phases, and that's what the purpose is for. Digital transformation is happening in all the industries. Of course, it is changing the direction of the AEC industry trends too. 20 years back, we worked with our data in standalone desktop computers. Then we started working as a group with the servers, and now our data is in the cloud. We are rightly using this technology and Internet of Things, considering the infrastructure and engineering. 3 decades before, we insist on the drawing-driven methodology to a model-driven, and now we are using the big data analytics and cloud computing to meet our engineering and design requirements. Transformation is happening in this process also, in the process industry also, from a CAD to BIM approach, and now many industries have started creating the framework for the digital twin also. Which is the digital replica of an actual operational facility. And this will be the very next future. There are different numbers of standards, different standards that can be produced, in terms of the standards, methods, and procedures to be used in a BIM project. There will be international standards, regional standards, or national standards, or even the corporate standards. The bottom 2 tiers are corporate and private standards. These are standards created by a particular organization, but it is not having a national level of relevance. The ISO 19650 standard is the international standard for managing information over the whole life cycle of a built asset using the building information modeling. It contains all the same principles and high-level requirements as BIM Level 2 and is closely aligned with the UK 1192 series of standards. ISO 19650 originated as a response to the inconsistent and poor delivery of information on construction projects, which resulted in the wasted time and effort. As a response to the UK BIM mandate and using British standards as a framework, this suite of documents support BIM implementation globally. ISO 19650 Part 1 is the document to support the concepts and principles of a project with BIM deliverable, and the Part 2 supports the delivery phase of an asset. Part 3, released last year, dealt with the operational phase of the asset. Part 4 is still in composing. Once released, this will be support the information exchange workflow. And the Part 5, released last year, follows the same framework of the PAS 1192 Part 5, which supports the security-minded approach to the information management. We can just go through another poll just to understand your familiarity with these kind of international codes. So I'm putting one more poll over here so that you can able to answer those. This poll will be available here for another 30 seconds so that you can answer it so that we can able to evaluate. Okay, so it seems some of are aware of the standards and some of are not. Let me continue with my session of this. So I put this graphic in the screen because all of the people may be familiar already with this, and this is the original identification of the BIM levels, level 0, level 1, level 2, as was originally identified in UK. And you can see a red line is drawn because it means to represent where we come as an industry. But actually, this diagram used for many years as means to understand the progression from a CAD to BIM, from a 2D to 3D, or from a very silo to a way of working much more collaborative. So in recent ISO 19650, this standard that the image has been now changed from a wedge shape to much like the image on the screen. And you can see the layers stacked on top of each other in a vertical fashion. Standard layer, information layer, business layer, and in standards layers, you can see the ISO 19650, the international BIM standard, and there are stages, of course. And this is just a progression from one standard to another, and the representation has been seen in some of these graphics. The second layer is the technology layer, where you identify the files, the documents, models, and the common data environment. Once you identify the two basics foundation layers, then you start getting the information layer where you can identify the different types of information. And once you identify the information layer, you can uncap the business layer, which is really understanding the increased benefits from the existing and the new digitally and enabled process throughout the different levels. Another vital part that we always been aware of is identifying the roles and responsibilities of parties involved in a BIM project. In simple terms, the BIM stakeholder relationships. When a project team is very small and if it is located in a single office, this might not be having much large undertaking. But these days, with a complex combination of organizations and global locations with people we're operating, it is vitally important that we are actually lay out and set them on the paper exactly who all key people in the project, and not only identify those people and their roles, but actually identify what their responsibilities are. It is also through laying these roles in a structured form that we actually fully understand the one person has to do with regards to the another, and we can eliminate any overlaps. In the ISO 19650 standard, the diagram on the left-hand side is the new representation of a particular project team structure with the appointing party or the client at the very central, identified here as A, appointing party. Then appoints the lead appointed parties to deliver the project, and here identifies as B, and subsequently they will appoint their appointed parties, identifies as C, which again will be their supply chain organizations. So again, it is important to understand the relationship between everybody and supply chain, and it is what is it is each of us expected to do in a project. And it is quite important that we record these things accurately, and therefore everybody is clear, very clear about what they are expected to do, and more importantly, what are expected to deliver as a part of a delivery of a project. Once again, the three important terms which is related to those involved in a project includes the appointing party, or the lead appointed party, and the appointed parties. The actors then comprise of the task team and delivery team. Everyone in the inner circle is the project team, and the parties inside this small great circle too is the delivery team. The solid dark lines indicate the mandatory information exchange, while the dotted are into the coordination. Means sometimes they have to coordinate, and sometimes they have to exchange the information. These are the key different acronyms associated with the information exchange process, and without understanding these, we can't understand the digital delivery cycle. The first one, the organizational information requirements. These are the information requirements to answer or inform very high-level strategic objectives within an appointing party, as strategic business operation, asset management, portfolio planning, policy making, and or regulatory duties. In simple words, it's emphasized on goals and objectives and the information identified for an organization to run. Asset information requirement, AIR, set out the managerial, commercial, and technical aspects of producing asset information. They are information requirements that relates to detailed pieces of information needing to answer asset-related questions. A set of asset information requirements should be prepared in response to trigger events during the asset operation. This is more focused on the assets of the organization has, identify what these assets are, and what information we need to know about these assets. Project information requirement. Before in UK level 2 standards, it's commonly said to be the plain language questions. The project information requirement explains the information needed to answer or inform high level strategic objectives, and maybe a set of questions that the appointing party may ask for themselves to answer high level strategic objectives. PIR is a subset of OIR, where the project information requirement talks about only a specific part of the project. One another vital document is the Exchange Information Requirement, EIR, and before in the UK level 2 standards, it was said to be the Employer's Information Requirement. So this exchange information requirement set out the managerial, commercial, and technical aspects of producing specific project information. This is information needing to be implemented and delivered by the appointed parties and delivery team. So EIR is the document that the order provides to its supply chain organizations, including the first and second tier, says it is the information they need and in what kind of format and when they have to deliver this information. So in simple terms, the EIR is the document that the client is about to share with their supply chain organizations. Next thing is the asset information model. So the asset information model supports the strategic day-to-day activities of the asset management by the appointing party. And the asset information model is specific to the appointing party and contains details that they have noted as a valuable and wishing to manage in a systematic way. Project information model supports the delivery of projects and contains all the information in a geometrical and non-geometrical fashion, and the appointed party would need to deliver in regard to the appointment and relative to the exchange information requirement. So this is a subset of a digital twin, which is more specific to the segment of the project. One another vital document is the BIM execution plan, or the BEP. Collaborative response by the supply team in order to demonstrate they are capable of achieving the information requirement or outlined within the exchange information requirement. Simply, this document is an answer to the exchange information requirement. Master Information Delivery Plan is a schedule of all the deliverables that will be produced as part of the project. Each deliverable is assigned to an organization and an individual who will be responsible for its production. Scheduled in such a way that before any supply team members begins to their work, they have the information required to do so. So the MIDP should form part of the BIM execution plan. Common data environment is a one important aspect if to be tell if considering a BIM process. CDE is a vital component in all these process, a single model environment that allows all parties participating in the project to share and exchange information in a collaborative manner. So information uploaded to the CDE will be checked, reviewed, and approved to ensure that it is correct. And we can go deep into this subject in later slides. In the new standard, the delivery of the project is very much requirement driven, and that's important, I would say, of the project to identify these key areas of information. You see there in the top left-hand corner, these organizational information requirements. As I said in the previous slide, this is the information required by the organization itself. That could be financial, it could be operational, or it could be human resource type information, and the information that is required around this organization itself. And then the asset information requirement, the information required from the project with regards to the assets that you are about to build and construct. It's vital these things and these requirements outlined at the earliest stages of the project, so everyone understands what is that you are looking to deliver over the course of the whole project. The information should be delivered in a way that it is clear and concise when in line with the appointed parties' information requirements. The information delivery cycle follows four overarching principles which are recommended as part of a BIM project. And this includes information needed for decision making, information that is specified and subsequently delivered, information requirements that are passed to one or more parties, and the information exchanges in regard to sharing and coordinating project requirements through the use of a common data environment. These principles should be applied in accordance with the appointed party's strategic approach to the BIM and the information management process recommended via the ISO 19650 codes. Another important aspects highlighted inside the ISO 19650 is the responsibility matrix, or the RASI diagram. Stands for responsibility, accountability, consulted, and informed. Depending on which task each party responsible or accountable of, also which task on which party consulted with, or which task on which party is informed about. So establishing this responsibility metrics at the earlier stages of the project orchestrates what information need to go with which party on what point of time. So it is considered as one of the key element of the ISO 19650. Another aspect that I would like to touch is the RIBA plan of work. The RIBA plan of works is a considerable document originally created by the Royal Institute of British Architects. And the plan of work was created as a plan of how to deliver a project developed over from the last 60 years. The RIBA plan of works, the latest update has been done last year in 2020 after it has been updated in 2013. So two specific stages has been added once it is updated to new, the stage 0 and the stage 7. The stage 0 is just added because there was an understanding that there is a strategic phase at the beginning of a project that need to be acknowledged. And in this strategic definition of the project is where the client's outcomes are identified, what the client is looking to achieve in its project. Stage 7 was added because there was an understanding that needed to cover the operations and maintenance part of the project too. So the RIBA plan of works is a document, is very much considered to be one of the best examples of how a project should be delivered, and it can be broken down on 7 or more stages as you see here. There are many other plan of works available in the world, and some have different classifications or groupings, so different stages. But the RIBA plan of work, of course, as it is originated in UK, is considered probably one of the best. And in its latest version in 2020, a new focus has been added with regards to the sustainability and that side of the project delivery too. Another aspect of the information management is the need to appreciate the problems that we had from a traditional approach. So the traditional collaboration between the various stakeholders on the project might be you see here, and this is where everyone has everything. And in other words, everyone's information need to be issued to everyone. You can see right the way the problems this is provided. There was manual circulation of information with multiple copies of information created, then held by all the different stakeholders in a project. So this is lot to be left no collaboration or communication and minimal cooperation because everyone feels that they have everything needed with themselves. There was no value and quality of the information because there was no consistency in regards to ensuring the everybody had the latest information. It took a while to search for the right information, and of course, there is no automatic workflows in it. So it probably delay the project by taking additional time for search for the right information, and this is one of the key problems that customers are facing. So this is why the role of the common data environment and why it is so vitally important for all the BIM projects. So this common data environment or placing all your information in a single location that can be managed and organized. This allows you the sharing of data from a single source of truth. Everyone can access the same version of the information from a central repository. This really enables true collaboration, communication, and cooperation because everyone is mutually working on the same side of the information. Data value and quality is maintained because of proper revisioning control and access control into the system that everyone is accessing. This allows for the key decision to be made, minimize the search time to find the correct information, and of course controls the ultimate handover from one stakeholder to the another, and the workflows can be automated. Part of the common data environment available in the ISO 19650, the standard actually specifies the workflows that should be used for managing information. It clearly tells you how to manage your information efficiently. So it identifies the 4 stages of workflow. The work in progress where the information is ordered and created, and then once approved and reviewed, then of course the information can be shared with the rest of the design teams by again from a central location or at a controlled access location. Once the shared information has made as possibly but through few iterations and is then reviewed and authorized to be used on the project, then it is published. And of course, the archived status is there. All the archived information that is to be used from all these 3 stages, and it includes ultimately the ultimate archive of the information in the end of the project. The transition from one stage to another should be the subject of approval and authorization processes, and these processes in a common data environment can be automatically controlled. The level of development is one of the key aspects that have need to touch with. The level of development concept encompasses several aspects of the design elements such as level of graphical detail or precision of modeling, or the amount of quality and relevance of non-graphical information, and type of non-graphical informations. Example, the embedded in the model elements, linked to the model elements as references or cross-reference model elements. When Essentially, when all these aspects are taken into consideration, this LOD represents the extent to which the information about an element can be relied on for the decision-making purpose at a particular point of time. So this is most crucial notion in the context of the collaborative working arrangement. So as part of a project, there will be key milestones, their informations need to be delivered. And in order to know how much information will be needed to produce as a set of project specific level of developments need to be established. These will inform the supply chain, the level of information required within their context. So basically, there are different standards available for the definition of level of development, and this AIA, BIM Forum, and the UK NBS are the commonly accessible set of standards available, freely available for all. To define the information delivery, a reference library of definitions are required. So the level of definition may be either described in terms of geometry or the information requirements. So the level of detail is regarded to be the level of graphical information, and the level of information, LOI, in some aspects said to be the ILOD, regarding the level of non-graphical informations. So basically, the level of detail or the LOD is basically more relevant to the design construction aspects of a project, while the LOI or the level of information is more vital to the operation and maintenance side of a project. So these kind of informations can be embedded into each on every project elements. These are similar series of tables with different names like LOD metrics or model information delivery table, and in general said to be the model production and delivery table. So when we talk about the LOD, we have to talk about this thing also. So this is vital in projects. What this does is like it lists every element that is being modeled, and in each stages it identifies what LOD the element should be modeled. OpenBIM is a universal approach to collaborative design based on open standards and workflows, though a software agnostic approach to allow for total interoperability. This means that when done correctly, this OpenBIM would allow the transfer of information between different project team members without any data loss. And there are particular topics that we have to touch with. And the first one is the COBE, the IFC or Industry Foundation class. It has no relevance with the issue for construction. It is the Industry Foundation class. And the BIM collaboration format or BCF. And finally, the Uniclass. And each of these is vitally important, not just that we understand what these are, or we understand the importance that they have in a BIM project. Just want to quickly identify these three processes and give you some examples of each. So COBE, as it says here, COBE data model is a subset of IFC, and COBE is for data exchange. COBE is very much used at the moment for when you need to specify what data exchange need to be done at the end of construction. As the handover, you don't have any operational or facilities management information to anymore to inform you as the information should be. COBE is used as a default data exchange solution. IFC, the Industry Foundation class data model, describes the architectural building construction industry data, and it's a platform neutral open file format specification. IFC contains both geometry and data. IFC is very much used to allow the interoperability between certain platforms. BCF or BIM collaboration platform is an open file format that allows the additional of textual comments and screenshots and more on the top of the IFC model layer for better communication between different coordinating parties. It separates the communication from the actual model. Uniclass, especially the Uniclass 2015, is a classification system, and it covers all the construction set items, and it is recommended by the latest standards. Uniclass is designed to cover all the aspects within the project, regardless of the discipline, regardless of the stage, and is a full-blown classification system allows unique identification for every elements that in a project, and also that will be looking to the model. There are furthermore open standard formats available to touch, like the information delivery manual, building smart data dictionary, or the model view definitions. So these can be covered in our future sessions in detail. COBie, like I have explained in the previous slide, is a data schema, an organizational framework that allows building information created in design and construction software to be exported to an owner's facility management software. So COBie is not a software application. It is not a data file format. Does not require any kind of licensing, and it does not require owners to exchange software or to disrupt the business process. COBie simply facilitates the information exchange, and the data fields in the COBie data table, it can be organized into a summary of lists that is meaningful to an owner. Industry Foundation Class IFC is an open and neutral form of data used to exchange the information between the AZ and facility management applications. IFC make it is possible to hold and exchange the relevant data between different software applications, as it is based on open data standards. And Uniclass 2015, which is the latest version of the Uniclass system, is now considered covering all the construction sectors. The earlier releases of Uniclass were lacking in some areas, but in 2015 has the now become the standard, basically being used on most of the projects, probably with the exception of the US, where the Omni class is the preferred classification system. It contains a consistent system of breaking the elements within the classification system, and you can see here that there are different folder structures, and quite often parent-child relationship between the folder structures exists. So without doubt, there is no logical reason why you will create your own system when such a comprehensive industry accepted model is available. So as part of the digital transformation in the industry and processes, we are moving into a digital twin program. A few of the industries has already started working with that, and more industries are coming closer to this program. And many nations are preparing the standards and framework for the digital twins. And we can take UK as an example with their National Digital Twin Program, which is run by the Center for Digital Built Britain. So basically, the digital twin is a virtual model of a building or asset, and this is an actual replica of an operational facility. And the day-by-day operations has been monitored by use of the artificial intelligence or machine data, or even using the advanced equipments like drones, or even by using the facilities like cloud computing. So each and every stages will be lively updated to the digital model from the actual operational facility. And this is considered to be the future of the current industry process. So I'm just concluding from here. So thanks for attending today's session, and we are happy to get engaged with you with more of our webinar series. After this session, you will receive a feedback survey request. So there, we mentioned our future webinar programs of this year. You can check your interested program so that we can schedule it based on the priority. And also you can able to specify your interested programs, even if it is not available within the list that we have shared. Now we can move to the Q&A session, much awaited.